Medical Waste Management, a comprehensive overview. Camera opens with the professor standing in a microbiology laboratory. Professor: Good morning, medical students. Today, we embark on a fascinating journey into the world of biomedical waste management. In healthcare settings, proper handling and disposal of waste are crucial to prevent the spread of infections, protect healthcare workers, and preserve our environment. Throughout this class, we will explore the intricacies of biomedical waste classification, segregation techniques, treatment methods, safety measures, legal frameworks, and more. So, let's dive in. Camera transitions to a whiteboard with the title Definition and Classification of Biomedical Waste. Professor: To set the foundation for our discussion, we must understand what constitutes biomedical waste and how it is classified based on potential risks. Biomedical waste encompasses various types of materials generated in healthcare facilities, including pathological waste, infectious waste, sharps waste, pharmaceutical waste, and more. Camera switches to a demonstration of proper segregation and packaging techniques. Professor: Proper segregation of different types of biomedical waste at the source is vital to minimize the risk of contamination and ensure safe handling and disposal. We will discuss the importance of color-coded bins, labels, and packaging methods to prevent cross-contamination and facilitate efficient waste management. Camera moves to a storage room with shelves filled with properly labeled biomedical waste containers. Professor: To prevent accidental exposure and contamination, healthcare facilities must adhere to specific guidelines and protocols for the safe storage and transportation of biomedical waste. Our discussion will encompass appropriate storage conditions, labeling requirements, and transportation regulations. Camera transitions to a medical waste treatment facility. Professor: Not all biomedical waste can be treated the same way. Solid waste, liquid waste, and sharps waste require different treatment methods. We will explore various treatment options such as incineration, autoclaving, chemical disinfection, and sterilization techniques tailored to specific waste types. Camera displays the incineration and autoclaving equipment. Professor: Incineration and autoclaving are commonly employed treatment methods for biomedical waste. We will delve into the underlying principles, procedures, and safety precautions associated with these processes, ensuring efficient destruction of infectious pathogens and reduction of waste volume. Camera focuses on chemical agents and sterilization equipment. Professor: Chemical disinfection and sterilization techniques play a crucial role in decontaminating and disinfecting biomedical waste before disposal. We will discuss the effective use of various chemical agents, such as chlorine-based compounds and hydrogen peroxide, along with the importance of proper sterilization techniques. Camera shows composting and anaerobic digestion setups. Professor: In our pursuit of sustainable waste management practices, we will explore alternative treatment options like composting and anaerobic digestion for the safe disposal of biological waste. These eco-friendly approaches enable the decomposition of organic materials while minimizing environmental impact. Camera presents a sharps container and safety tools. Professor: Proper handling, storage, and disposal of sharp objects are critical to mitigate the risk of needle stick injuries and infections. We will emphasize the adherence to safety measures such as using puncture-resistant containers, employing safety-engineered sharp devices, and implementing sharps disposal training programs. Camera showcases radioactive waste storage areas and disposal processes. Professor: Radioactive biomedical waste poses unique challenges. We will discuss the protocols, guidelines, and safety measures for safely handling, managing, and disposing of radioactive waste in compliance with national and international regulations to prevent radiation exposure risks. Camera displays waste minimization strategies and recycling initiatives. Professor: Waste minimization and recycling practices play a vital role in reducing the volume of biomedical waste generated and minimizing its environmental impact. We will highlight the significance of source reduction, recycling of materials, and the implementation of sustainability programs. Camera focuses on legal documents and posters displaying regulations. Professor: The management and disposal of biomedical waste are governed by a range of national and international regulations and legislation. We will explore these legal frameworks to ensure compliance, accountability, and standardization in healthcare waste management. Camera shifts to a discussion on safety measures and personal protective equipment. Professor: Handling biomedical waste carries inherent health risks for healthcare workers and the public. We will address the potential hazards and discuss the importance of implementing comprehensive occupational health and safety measures to protect all stakeholders from infections, injuries, and other potential risks. In conclusion, we have explored the various aspects of biomedical waste management, including its definition, classification, treatment methods, safety considerations, legal aspects, waste minimization, and recycling. By implementing effective waste management practices, we can protect human health, the environment, and achieve sustainable healthcare systems. Thank you for joining me on this enlightening journey.